Hello, welcome to the week 12. This lecture, we are going to discuss the sorting, and it's going to be just one part for this whole week. Okay, so weekly objectives are this. We have been studying various types of the data structure so far, right? We have studied, right, the linked list and the stack and queue and the let's say tree, binary search tree, and priority queue with the tree implementation. That's the binary heap, and then that's about it so far, right? And we are going to study the graph structure in the next week. So that will conclude our semester. Having said that, we also study various types of the algorithms. For example, the selection sort, and then what? The merge sort, right? And also, we have seen that there are various types of the insertion and deletion algorithms, and then also dynamic programming types of the algorithm, and also recursion based algorithms as well, right? So actually we studied a lot. Here the objectives are actually understanding their performance, particularly why do they have such kind of performances. And to understand the performance, you have to understand the mechanisms of the algorithms. So you have to understand the algorithms. So if you understand the mechanisms of mechanical, how it works, the mechanics of that algorithms, then you should be able to implement that. That's the selection sort, merge sort, heap sort, quick sort. And then this is the new thing, right? Quick sort and radix sort is order of n search, and also based upon order of n sort, order of n search space, order of n sorting, right? So actually that sounds really great, right? But of course it doesn't come easy, but we are going to discuss that. So we already talked about selection sort, merge sort, and heap sort in the previous lectures. Quick sort and counting sort, radix sort, these are the new things. So sorting is very important, and sorting is and also everywhere. Let's imagine you want to analyze this financial data. First, what you want to see is how what does this table means. So symbol means like the ticker symbol stands for each company, and this is the company name, right? And the rest, when it was traded, and the changes and the volume. So this is the how much it was traded and the how much the trade price has been changed, right? When you see these types of the numeric information, what you want to see is eventually and instantly, what you want to see is the max and mean, finding max and mean. That's the start of the analysis, right? Finding the range of a numeric values. After finding max and mean, what you want to do is next is calculating average or and so forth. And after doing whole things, what you want to do is write the charting the histogram or write distributions. When you want to do this, what actually you have to do is what? Actually, you have to sorting, right? You have to sort these values, and you have to find the buckets, and you have to count the frequency, and then you show your distribution in the analysis. So actually, even though we are doing this kind of simple data analysis, the sorting never goes away. It just stays here, and you have to do it. So without the manipulation on data, it's just chunk of data useless to actually users and analysts. And data should be structured for the users. Data display may be this can be sorted, and so sortable table. Computers is data structure, binary search tree, heap, or hash, and so forth. So most of human decision makings asks this maximum, mean, or average cases, and these all requires some types of this sorting. So the most basic sorting algorithm is the O of n squared sorting. O of n squared sorting algorithm is the worst case of O of n squared sorting. So this sorting algorithm particularly doesn't involve any divide and conquer approach. It's just similar to the linked list, because linked list does not implement the divide and conquer. When you have divide and conquer in the linked list, we can turn that into the binary search tree, right? So without divide and conquer, how it works is that sequential comparisons with two index iterations, right? Usually there is a nested loop that ranges. Outer loop is from first to the end, and there is another inner loop that goes in between the outer loop's start index to the end. Outer loop's start index to the end, like this. So when index 1 is pointing at number 5, then the inner loop starts from the number 6 here, like that. So how these two loops interact with determines the variance of the sorting algorithms. There is an insertion sort, there is a selection sort, also there is a bubble sort. Having said that, if you just see how it works here, and here, and here, like this, like this, you can see that there is always two indexes. So here we have black box and red box. We have this red square and this blue square, and this index and this index as well. So you always can see that there are two indexes iterating. So pros and cons. Cons of the bad side is the time complexity, because the O of n squared is kind of expensive algorithms. Pros, easiness is that it's very easy to implement. If you can just implement for loop, it's very easy to come up with these sorting algorithms. So let's see an example of that. The selection sort algorithm. For example, let's observe how it works here. So it started from one index is pointing here, and how it works is that the other indexes move through from here to here. Actually, this one is pointing. This one has this outer loop, and this one has this inner loop. And then this outer loop, when pointing at 0, this inner loop starts iterating from 1 to 7, right? And then compares it whether it has a higher value or lower value compared to the outer loop's index. And based on the ascending order or descending order search, we exchange the value. So this outer loop is specified here, and the inner loop is specified here. And this here, it was stopped around like this. And how it this index and this index values are together compared with this if statement. And based upon the ascending or descending orders by these inequalities, there is an exchange of the values. All right. So examples of the algorithms have the insertion, deletion, or search, and so forth. And also we have sorting algorithms. and selection sort we already covered in the previous lectures have these structures. There are two iterations like this, and then here the if based upon the descending or ascending orders, we have this inequality, and we swap the values. Actually, you can learn from 0 to length and the inner loop 0 to length, but it would be faster to have this ITR plus 1. But it doesn't matter whether it runs from 0 to ITR plus 1. In the big picture, it doesn't change the order of n square logic, and the even though we search from the 0, it doesn't swap because it already covered from 0 to ITR iteration in the inner loop. So this program actually uses data structure, list, and algorithm is the selection sort. So example of the selection sort execution looks like this. So we have this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, 10 values to sort. So how it works is that ITR1 is the outer loop, and this is the inner loop. And this ITR1 iterates from 1 to 9, right? And this inner loop iterates from 2 to 10, 3 to 10, and 10 to 10. And each of these iterations results in this number of the comparisons: 9 iterations, 8 iterations, and 1 iteration. So total iterations count is that from 9 plus 8 plus 2 plus 1, and that will be 45, right? And that's the 45 iterations. And it is actually structured in this way, right? So that is how it works, is that like this, n1, right? And there is I starts from n1 to n minus 1, n minus 1, sorry. J is the I, right? Plus 1 to n. If you just calculate this, and then you will have this one.